Hey guys, welcome back. So today we're working on what is probably Generac's largest portable generator. It is rated at 17,500 watts, and this is a model I've been looking for quite some time. You know, brand new, they sell for about $4,000, and even used and non-running condition, they usually sell for at least $1,200, and they sell pretty quick. So I've never actually been able to get a hold of one, at least until today. You know, this one I found on Facebook Marketplace. The guy selling it was only asking $850. You know, he actually won this at an auction. He says the engine rotates, but it doesn't run. And he's actually never heard it run. So, you know, I am taking a pretty big risk at buying this. You know, for $850, you know, I'm taking his word that the engine rotates, but I don't even know if the engine's going to run right or if the generator is going to make power. But I'm willing to bet it might because, you know, looking at the hour counter here, there is only 146 hours on the clock. So, yeah, this machine, it is pretty young, at least as far as the hour counter goes. So I'm thinking before digging in too far on this, I do want to just get the engine to rotate and make sure that we're not dead in the water here. So, you know, this model, it is electric start only. And of course, the battery is stone cold dead. So, you know, I say we start there. Let's get a new battery in it and see if the engine does, in fact, rotate. So I'm thinking, let's start right here. We'll get this protective screen off the flywheel fan, and we'll just get a wrench on the crankshaft and make sure we can make a full revolution. Moment of truth. And yeah, the engine rotates just fine. I do feel compression. Good. I think we're going to be okay. So I'm thinking, let's check the oil real quick and get a good battery in here. We'll rotate it with the electric start. Make sure we build oil pressure. Yeah, we've got plenty of oil. It actually looked a little bit overfilled, so hopefully that's not water. And yeah, we are overfilled. I'd say by about half a quart. So we'll have to keep an eye on that. You know, I don't see any evidence of water, but after the machine runs, that might change. And to be fair, though, this machine isn't exactly level either. Let me show you. So those wheels right there, they are not original to the machine, and they are a little bit oversized. So because of that, the engine is sitting higher than it should, and the generator side is actually sitting kind of lower than it should by a couple inches. And that might be why we're getting the oil reading that we're getting. Now, on most machines, that might be a concern because a lot of generators, they are just splash lube, at least of the portable generator variety. But this actually has an oil pump. So because of that, you can have a steeper angle without having any negative consequence. So I don't think we're going to have to swap those wheels out, but it is something we'll keep an eye on. So let's actually pull the airbox cover off. You know, likely we're going to have to pull the carb anyway. And when I went to go pick this up, the airbox cover wasn't completely off. It was just kind of unscrewed and cocked to the side. So I never actually got a good look inside. So I want to make sure we don't have any kind of a nest or any other concerns going on. And actually, it looks like there was a critter in here at some point. You can see kind of some remains right there. We also have a good chunk of the air filter missing there, although there is a metal screen, thankfully, so the critter could not get past there. But I'm thinking, yeah, let's vacuum that out, probably pull the filter out, and just clean up that air box the best we can. Just going to get this filter out of the way. Can't really clean underneath it. Not really sure if there's any junk kind of on the other side of it, so I think it's better just to probably get rid of it for now and just clean up the air box. And yeah, there is some debris on the other side, so I don't think it was compromised. It was just chewed up and maybe a little bit sucked through, if someone was cranking the engine. So yeah, not a good thing, but at least the engine's not stuck. So all the loose debris, it's been vacuumed out or blown out. And we do need to get a new filter ordered up. But until I know that this is a viable machine, we are not going to place that order. So I was getting ready to swap in a new battery. And actually, I noticed a problem right here with this fuel filter. The first issue is that we are missing a clamp. And this line is about to fall off. But more concerning is the color of the fuel inside this filter. It actually looks like water, and I would pretty much bet money on it that this is 100% water. So like that, this engine has no chance of running, and likely the carb is full of water as well. So we are going to have to purge the system before trying to start it. But for now, let's get the new battery installed. We'll deal with this issue, and then we'll try to start it. Looks like someone already did the work for us, at least on this side. Yeah, actually both sides. So the battery wasn't even secured when I transported this home, so I'm lucky I didn't end up losing it. So it looks like 2, maybe 7/16. We'll get this one out, get the new one in. Well, not quite the same. It looks like, well, the positive's on the other side, so I have to install it like this so that the terminals are up front, which actually is a problem because the strap that holds it down is going to short the terminals out. So this battery may not be the solution here. So like this, we would need the positive right there and the negative over there. So yeah, not ideal. Let me see if I have any other batteries. So I think we're just going to swap out the negative cable. I do have another one that is longer. So if we use this one, we can have negative over here and move positive to the left. And with that, we should have electric start. Beautiful. And we do. It sounds like we have compression on both cylinders. So I'm thinking, let's get some good fuel in that carb. Potentially it might run the engine. So we know we're full of water currently. So let's pull that line off from the carb. We will crack the screw to drain the bowl, and then we'll plumb in some fresh fuel and give it a try. I'm going to disconnect it here as well, since it's pretty much disconnected itself. So what just came out of there actually does kind of look like fuel. Yeah, and it smells like fuel as well. So maybe I misread this. Let me crack that valve open and just see if fuel comes out or if water comes out. I think I misread that one because the fuel that just came out is 100% fuel. There is no water in there at all. So, I think it was just the filter kind of making it look like water instead of fuel. But, the fuel does smell good. It's a little bit old, but not too bad. Like the engine should run just fine on this stuff. So I am going to give it the benefit of the doubt. And we'll just get this reconnected and we'll try to start it as is. I think eventually I'm going to eliminate this too. There's already another fuel filter in the system. This one's kind of redundant and it's not really going on the fuel line very well. So I think even with a clamp, it's probably not the safest thing to run. So I'm not going to hold my breath on this one. The guy selling it says it doesn't run. But just in case, I do have the kilowatt plugged in as well as a light plugged in and turned on. So I will get the choke applied and we will crank the engine. And with any luck, it'll start. And we get absolutely no signs of life. So either the carb is really clogged up or we have some other problem going on here. So I'm thinking, let's give it a little bit of starting fluid. If we have spark, compression, timing, the engine should come to life, at least for a second. And potentially that'll be long enough to see if the generator makes power. Okay. Okay, good. The engine, it kind of ran. It ran a little bit, at least under its own power, but it didn't get up to speed. So the light did not turn on, but I'm not too worried about that. This still told us a lot. The engine sounds good. We know we have spark, timing, and compression. Fuel is the thing we're missing here. So getting the carb out, it's going to be a bit of a challenge. This is the same type of carb that's used on the XG10000, and that one is very complicated, mostly due to the airbox design and the inaccessibility. This airbox I don't think is going to be a challenge to get off. There's just a few nuts on the back side holding it, kind of sandwiching it between the carb and the intake. So we'll get those nuts removed. Airbox should come out, free up a few lines, but I think the biggest complication here is going to be the choke mechanism. The linkage, it is not removable, at least without disassembly of some of this stuff in the front. So, I think if we remove these bolts, it'll free up this front panel, and with any luck, we should be able to slide this choke mechanism out of the way. And then we also have a few wires. This governor, it's not mechanical, it's actually a servo. So there's some wires for that we have to disconnect, as well as the fuel solenoid. All right, that was the connection for the fuel solenoid. And the servo wires, I actually don't see where those disconnect. Maybe they're on the other side here. And actually, I don't think we need to disconnect the servo wires. We can just probably free the connection from the carb right here. My concern, though, is that the linkage actually looks bent. So it may not be usable in its current state. Okay. Yeah, this approach might be flawed. The oil dipstick tube is in the way, so I can't actually pull the airbox off. So really the only way to do this is to pull the intake manifold, which I was trying to avoid. But I think that might be the path of least resistance here. So now we're back to having a problem with the solenoid because the wires, they don't seem to be removable. So I could probably pull this whole thing out and then remove it. But there's got to be a better way. So yeah, there might be a way actually to release the solenoid. I do see a bolt right there, and I think there's one on the other side. And I think we can finally, I was going to say, finally slide the carb off the studs, but the gasket is now holding us back. So let's tap that a bit, see if we can break the carb free without destroying that gasket. So we got our prize. Definitely more work than it should be, in my opinion, to get a carb off, but we did get it off. The gaskets all survived. So I think we can get it back together once the carb is cleaned up. My only concern here is the linkage for the servo. There is a bend in it, and I'm not sure if that is a factory bend or if that was done by someone potentially trying to get the carb off. I'm not sure. So I'll have to research that a bit. But for now, let's get this carb cleaned up. All right, let's have a look inside this carb. Now, this is a double barrel carburetor. So the fact that it wasn't running at all would mean either both main jets are clogged and both pilot jets, or I would say more likely, maybe the needle is stuck, or the fuel solenoid is stuck. Potentially it's just a bunch of debris. But the fact that the drain seems to work is promising. And the fuel that's coming out actually is kind of green, which is a little odd. Yeah, a little bit of varnish on the tip of that, but not too bad. No water in the fuel, but the color definitely isn't right. So I'm going to try to remove the fuel solenoid before getting the bowl off. And actually, I just got a whiff of this fuel. It does not smell good. So although the fuel in the tank doesn't seem to be bad, I would say it's probably been in there for a while and should be drained from the tank. Wow. And that is really stuck on there. That is not a good sign. Let me try maybe a deep well socket. So hopefully this does it. I'm going to use the deep well socket with a breaker bar. So something's going to give. And hopefully it's not the carb, because these I don't think are cheap. Okay, let's leave that on there for now. It is not budging. And I think my odds are going to go down with the bowl detached from the carb body, but, you know, it may not be clogged, so let's not break it if we don't have to. Okay. It's actually not too bad in here. The needle, though, it is stuck. So that is a good reason why this wouldn't run. And when looking down here on the bottom, that pin has a ton of varnish on it. So even if the needle wasn't stuck, I'm not sure that this pin would move. And the default position is that it's deployed and blocking the fuel flow through those passages, which are the main passages for the main jets, which also look to be varnished up pretty bad and maybe clogged. So yeah, I might need to get a rebuild kit for this, because usually when the needles stick like this, you know, getting them out can be destructive. But let's try. Gonna spray a little bit of PB Blaster around the needle and also the fuel inlet. You know, that might help free this up. And no, that's not going to come out. I was hoping I could sneak the float out, but yeah, if I do that, I'm going to damage the needle. And right now it's just stuck. It's not actually damaged. So I'm likely going to soak this in the ultrasonic before trying that again. Let's see if the main jets will come out. And no. Those main jets are stuck as well. And then on the top here, we have the two pilot jets. They're held on, or they're held down by this washer and this fastener right here. So what I usually do is take the Dremel and slot this out. There is a special bit you can get and just use this as is, but I don't have that bit. Before I try the Dremel though, let's just see. It might just spin out. Yep, that broke free. And we'll pop those jets out. There are O-rings on them which tend to turn brittle and crack, so it's important to inspect those on this. Otherwise it'll be a vacuum leak and likely cause surging. And I think this one's actually broken. Yeah, it's coming off in pieces. Can't really see it on the black glove, but it's right there. So yeah, that is a problem. It's the same type of O-ring though that Honda uses on their pilot jets. So I might be able to scrounge up a few. And this one's intact, but it does feel petrified. So yeah, we'll get those replaced for sure. So yeah, let's give this a 5 or 10 minute soak and we'll see if any of the stuff is freed up. I was able to loosen up the fuel solenoid, so I didn't want to run this through the ultrasonic. Although it's meant to have gas kind of on the side that has the pin, I'm not sure that side would be quite as forgiving. So a quick 5-minute soak, and that bowl looks nearly spotless, and the carb isn't too bad either, but the needle, it's still stuck. So I might soak it a little bit longer, but I'm thinking, let's try pressurizing this a little bit, and that might be enough to get the needle unstuck from the seat. Well, we lost the tip, not of the needle, but of the tool I was using. And the needle did move a little. There we go. So good. Usually I don't like soaking these in the ultrasonic, but this needle, I'm going to make the exception for. We need to get all that varnish off the sides, or else it's not going to operate correctly. But that should do. The solenoid, it is stuck in place. So yeah, I might try to free that up maybe with some WD-40, but I'm thinking that might also have to soak in the ultrasonic. And it's either going to make it or it's not. But in the state that it's in right now, it's definitely not going to work. So let's have another go at the main jets. Nope, that one's stuck. And that one is also still stuck. So I'm going to try a little bit of heat, and maybe that will allow them to spin. Got one. And we also have an emulsion tube in there, which I don't think is removable on this one. So let's apply a little more heat to the other jet. And I think it'll come out. There we go. Okay. So the carb body is looking pretty good. And the jets are not, they're not blocked. But they are varnished, so we will clean those up. Let's try a little bit of WD-40 on this. See if we can get it to move. Yeah, zero movement out of that. So let's try cleaning it with the wire wheel. I don't think that's going to free it up, but we can at least get the junk off that we can see. And we'll try it again. If that doesn't work, then I think we're going to have to resort to the ultrasonic on this one. Nope, it's not moving. We get a little bit of movement out of it now. So on some of these, you can actually pull this piece out. I'm not sure if this is one of those. Oh, I think it is. So that is what we're fighting with there, all that buildup. So this I can drop right in the ultrasonic. That'll take care of that. And I might have some sort of a wire brush to get the inside of that. Well, surprisingly, everything cleaned up really well, and nothing was damaged during the process. So I'm happy about that. You know, I give this carb a pretty good chance of running. You know, even the plunger cleaned up well, and it moves freely now in the fuel solenoid. So I think that'll work. And I was also wrong about the emulsion tubes. They are removable. They were just glued in with varnish. So as soon as this ran through the ultrasonic, they just kind of fell right out. So let's start by getting these tubes back in, as well as the main jets. And I did also wire wheel the threads because they were pretty corroded and gummed up, and that's why they were so hard to get out. And as far as the pilot jets go, you know, these are essentially Honda clone pilot jets, at least their form factor. So, you know, I don't have a stock of those O-rings, but I do have Honda clone carbs, and this one is brand new. So I think I'm going to borrow the O-ring out of here, and, you know, I'll just replace it later. You know, the parts will take a few days to get here, and there's really no reason to wait when we have them sitting right here in this carb. Although I can tell already this one's a little different because they're green. But I don't think that's going to matter. Just makes it easier to see. And these are hard to get off. But we got one. That should solve that problem. And let's see if we can grab the other one and put it on the bottom of this jet. You know, this one down here, it is pretty petrified, and I think it's just going to break. So this one is brand new. And yeah, that one just broke with very little effort. Although I'm not liking how it's kind of stretched out. Let's see if that's going to drop in. Yeah, seems to be fine. You know, if it ends up running lean, it's easy enough actually to swap these out on the machine because this is right on top. So we'll give it the benefit of the doubt. But those feel like they made a good seal. Okay, let's try it out. So we'll connect this linkage back up. And I did go online. I took a quick look at the parts diagram for this machine, and there was a picture of this linkage, and it is supposed to be bent. So that is a factory bend. There we go. So we'll get the airbox situated. This was also run through the ultrasonic to get the remnants of that mouse nest out. Well, I think we're as ready as we're going to be. I got this control panel back in place, the choke is hooked up, and we're also plumbed into some good external fuel. I've got the light plugged in, the kilowatt on standby, and I've also propped up this side just to help level it out a bit. So let's turn the choke on, and we'll crank the engine, and hopefully this thing comes to life. That servo has control of the speed, and that light turns on. All right, that was pretty good. I was a little nervous about this one. This machine doesn't have a lot of hours on it, and I'd say it's been quite a while since it last ran. But now that the carb is cleaned up, this thing came right to life. I was able to turn the choke off right away. The engine continued to run nice and smooth. And not only that, but the light turned on almost immediately. We were at 125 volts. The electronic governor found 60 hertz pretty fast. We were just over at about 60.6. So the vitals, they're looking pretty good. So I think, now that we have some heat in the block, we should probably get the oil changed, and then we can move on and finish this up. Well, that's not going to work. All right, let's see how we did. A lot of oil came out. I only added back 1.4 liters, which is all you're supposed to put in here without an oil filter change, which I had planned on doing, but actually the Wix filter I have, it is for a Generac 8000, XG8000, but it's not compatible with this machine, so, we will add oil filter to the list. But yeah, 1.4 liters is perfect. We're right on the full line. So that should be good. Let's measure out what came out, because I think we had a lot more oil in there than I thought we did. So there's 1 quart plus a little bit more on the ground. And this oil is really thin too. I know the engine was just running, but it kind of smells like it's diluted a little bit with fuel. And yeah, it was way overfilled. So right there, that's about another 800 milliliters. So we're at 1.8. And when you factor in what's on the lift table, it's probably closer to 1.9. Definitely overfilled. So I'm going to get the contents of the tank drained, and I'm going to use these clear bottles at least to start with. I want to make sure 100% that there is no water contamination in here. So the fuel is still draining. We've gotten about 7 gallons out so far. And I think we're just about done. But I've been cleaning up while the fuel's been draining. And this stuff, it's not really dirt or oil. I'm guessing it's mold because WD-40 isn't really having much effect. So let me try some goof off. So I've already pulled off the fuel line that runs from the tank over to the pump. And although it's not cracked, it is petrified, and I will end up replacing it. And I'm also going to replace the filters as well. Although they're not dirty, someone did cut the barb off this one, and as a result, it's not going to hold a fuel line very well. And also the order these filters were in also didn't make a whole lot of sense because this filter is the finer, lower micron filter. That one should be second, and the higher micron filter first. So we'll put a screen type filter on this side, a paper filter over there, and then I guess the last thing of concern here is the routing of the fuel line. This originally was going in between the frame and this sharp piece of metal, which I'm not crazy about that idea, so I'm going to route it instead just on the outside, which also isn't ideal, but I think it is the better of the two choices. Well, it's been a few days, and I think we have everything we need to finish this up. I got an OEM maintenance kit, which includes a new oil filter, air filter, and a new set of plugs. And I also got an aftermarket set of wheels. These were a lot more affordable than the OEM ones. The OEM were about $140 for a set, and that does not include tax and shipping. So, yeah, not ideal, because these are actually 13-inch and the OEMs are 12.3. But You know, after taking some measurements, I think those will level this out, at least get it a lot closer than where it was. So we will start with that in a minute. And the last thing here worthy of note is that I did get some new O-rings for the pilot jet on that carburetor. I already pulled out the used ones, put the new ones in, so that is good to go. It is a tight fit. So that's not a good sign. Let me see if I can get that off. I'm just going to try to clean up the shaft a bit, and we'll do this again. I don't know. That's the problem with aftermarket. It's so close, but it might be the difference of metric versus imperial, being that these were made, well, overseas. It's not a good fit. I guess we can try the other wheel, see if it's any better. Yeah, and that one fits perfectly. So the issue wasn't the shaft, it was the wheel. So I'm going to sand that other wheel just a little bit, and we'll try fitting it to the other side. Yeah, same issue over here. So the inner race on this ball bearing must be a little bit out of round. There we go. Yeah, that looks quite a bit better. So these wheels, they are still a little bit too large for this machine, but now it's an inch lower. And at this point, you know, not perfectly level. You know, I'd say we're still about half an inch off, but it is a lot better than where we started. It's been on there a while, I think. Wow, that is tight. that is on there. It's on there so tight I punctured a hole in it. So we're gonna make a bit of a mess here. Plug that came out actually looks decent. So the engine's was running pretty good at one time. And this one looks, I would say, better. You know, we have that nice brown color. So good. Plugs weren't too bad. Let's get the new one in. We'll make sure this tube is in place. This is actually a pickup for heat off of the exhaust. And there's actually a lever in the front of the machine you can pull, which will divert, you know, the air intake either from the warm air off the exhaust or cool air from the outside. So for winter operation, you know, you want to switch it so it pulls the air off the exhaust, which will keep the carburetor from icing up. And I'm just noticing a problem. Not a big problem, but you can see the top not exactly straight. So when you twist it in, although the bolt's going in straight, it kind of looks lopsided from the top. Well, I think I'm ready to try this, but to be honest, I'm a little nervous. This is a big machine, and it's going to be the heaviest load I've ever tried to put on a portable generator. So, you know, technically this is rated at 17,500 watts, but I question if anyone actually gets that from this machine, because the largest single plug on here is the 50 amp plug, and that maxes out at 12,000 watts. So that's what you would connect to your house. So it's very unlikely that anyone is actually pulling more than that from this machine. That said though, it is possible. And that is really the concerning part here, is because although everything has a circuit breaker, there is no master breaker. So when you add up all the breakers, you can actually pull up to 31,000 watts and not trip any circuit breaker if you have everything balanced properly across all the outputs. Of course, the engine isn't capable of that, but just the way that it's designed, you're either going to pull too little when connected to your house, or potentially too much, depending upon how you're using it. So in this case, I'm going to try to get 16,000 watts out of it. So I'm going to get the engine started. While it's warming up, we'll double check the outputs. We use the kilowatt to measure the frequency and the voltage. We use the oscilloscope to see what the sine wave looks like. And we're also going to use the amp probe to measure the harmonic distortion. And that I'm very curious about. I'm expecting it to be pretty low, given the fact that this is a multi-cylinder engine and has a very large stator on it. So once the engine has warmed up, I'm going to use these space heaters to put a 6,000 watt load on it. Assuming everything goes well, I will then switch over to the load bank, which is capable of 10,000 watts, and we'll start to bring the load up. We'll see how far we get. All right, so no issues at all getting the machine started. Without a load, we are starting at 5.2%. And the sine wave looks pretty decent. So let's turn the space heaters on for a 6,000 watt load, and we'll check back and see how it's doing. Alright, so I just put on 6,000 watts of load, and the engine didn't even blink. It didn't even notice the load, so that is a good sign. All the vitals look good, but the THD disappointingly came up quite a bit. We're at 22.5%, and I would not say the sine wave looks very good. So let's bring the load up some more. We'll put on maybe a quick 4,000 watts. So now we're pulling 10,000 watts. The engine responded really well. We're at 26.4. Sine wave looks pretty much the same. And the engine speed is doing very well. So yeah, let's bring up the load. 1,200 watts, 1,400 watts, 1,500, 1,600 watts. All the vitals look very good. We're at about 61 Hertz. THD came up again. We're at 28.5. And the sine wave pretty much unchanged. So let's give this a few minutes. Make sure there are no surprises. So no issues at all pulling 16,000 watts. So I'm going to go for the goals here and try the heat gun. So that's going to be another 1,500 watts. And that is on high. Vitals are good. We're holding at 61 Hertz. Pretty much everything is unchanged. So yeah, pretty impressive. So let's take the loads off and give everything a chance to cool down, and then we'll shut it down. Noticing the choke is kind of vibrating out. You can see it's doing it slowly. And after I took the load off, I was just waiting for things to cool down. And the engine started to act like it was going to stall. And I realized the choke had worked itself fully out. So I have seen this problem before on some Generac XG8000s. And I'm not sure if there's an easy fix for it. We might have to replace it. But yeah, if that's the biggest problem, then I think we're doing pretty good. So the load bank, it has cooled sufficiently. We'll power that down, and I'm going to run the engine or the car out of fuel. So before testing this, I was definitely concerned. I had my doubts as to whether it could pull 16,000 watts, but it had no problems doing it. So I threw on an extra 1,500. That brought us up to the max rated of 17,500. And the engine didn't miss a beat. You know, I'm certain it could have taken more, but I didn't have any more to throw at it. So the engine is very good on this machine, but the generator was kind of a letdown. The total harmonic distortion was pretty high. You know, we topped out at about 28% THD, which is definitely among the highest of any machine I've tested, and pretty surprising and disappointing given the cost of this machine. You know, I would have thought it would have been at least 10% or less, but that unfortunately is not the case. So overall, really no concerns about this machine as far as its run condition. Really the only thing we discovered is that the choke doesn't like to stay in the off position. And this is actually a pretty common problem on really any Generac I've tested that has this type of choke. It just works very effortlessly, and it doesn't take much vibration from the engine to work that choke out. So I could replace it and hope that the new choke doesn't work as well as the old choke, but I think that likely will not be the case. I think the only solution here is probably something mechanical to keep the choke in the off position. But for the purposes of this video, I think I'm done. So I hope this video helps someone. Thanks for watching. All right, a little bit of bonus footage here. I did pull off the airbox cover, trying to see if there's any adjustment I can make to kind of lock this in. And there really isn't. So I think, ideally there'd be a detent here, which I don't think there is. So instead, I am going to use a mechanical means to kind of keep this in the off position. And this is pretty flexible, so you can bend it out of the way to get the engine started with choke and then lock it back with the choke in the off position. Is it graceful? No. But does it work? Yes.